So in this question, we asked to find the time response C of t for this particular system C of s when a unit step function is applied to it. So this is the system C of s. At this point, we can just start doing our partial fraction decomposition for it. So it will be a over the root s plus b over s plus j w n plus c over s minus j w n, because they are all individual roots of their own. So this is the split. Now we can take the LCM of this. The LCM will simply be this again. So this is going to be, so for A, this into A is going to cancel out S, leaving you with S plus JWN and S minus JWN. Now plus B. For B, this will cancel out, leaving you with BS S minus JWN. And for C, this will cancel out, leaving you with CS S plus JWN. So now these two denominators will cancel out, leaving you with only the numerator. For to find A, we can say let S be equals to 0. That will make this and this to go out. So we left with W square N. Sorry, I forgot N. Because what? A G W N, because S is 0 here, and minus J W N. Now G square is equals to minus 1. That means minus J times J will be equals to 1. So this is going to leave us with Wn squared equals to A. This will become 1. Then Wn. Divide Wn squared on both sides. You're going to have that A is equals to 1. So we found A. And let's move on to B. For B, we can say that let S be equals to minus JWN. So if you equate this here, you're going to find out that this will cancel out because minus JWN plus JWN is 0. So that will cancel out and this will also cancel out. So we'll be left with WN squared is equals to B times minus JWN minus JWN minus JWN. Don't forget this S here. This will become B times minus JWN to be minus 2JWN. When you multiply these two, you're going to have that WN squared is equals to B times 2J squared and WN squared. Because this is minus J times the minus and minus. So, and remember that J squared is equals to what? Minus 1. So this will become WN squared equals to minus B 2WN squared. You can divide WN squared and 2 on both sides. You're going to have that B will then be equals to 1 over 2. So now we're costing B. Now to find C, sorry, we can say let S be equals to JWN. So in this case, this will cancel out, leaving you with this. So you're going to have WN squared equals to CJWN JWN plus JWN. This will be 2 JWN times JWN, leaving us with WN square equals to C 2J square WN square. Then from here you can simply divide WN square on both sides. J square is minus 1, so this will become minus C. You can divide 2 WN on both sides, leaving you with 1 over 2 equals to minus C, which becomes C equals to minus half. So substituting back into the original equation that we had, we're going to have CS is equals to 1 over S minus 1 over 2. This for B. S plus JWN minus 1 over this for the C part, 2S minus JWN. Now to get the inverse Laplace, we can use the inverse Laplace table here. For 1 over S over here, you can see that the inverse Laplace is 1. So C of t is equals to 1 minus. For this one, this is a constant, so we'll bring it out. So it we have times 1 over S plus J WN. We'll look for something similar. You can see it at this point. But in this case, A is equals to JWN. So this will become E raised power, since it's plus B minus JWN. Then for the last one to be minus E raised to power, this is S minus, so it to be positive JWNT. And don't forget your constant half. So now there's an identity, call it the Euler's identity. So with this Euler's identity, we can actually simplify this too. So C of t will be equals to still the same one minus, but in this case this will be cos. In this case theta is WNT. So WNT. So this will be a final answer simplified. Thank you for listening.